Okay, welcome back. And so today we're going to talk about the next basic function, which is the squaring function. Okay, so this is where all parabolas come from. We're going to talk about that later, but this is going to be the basic squaring function that you're going to want to know for this class. Okay, so what does it look like? Well, like I said, it looks like a parabola. It has this form of f of x equals x squared or y equals x squared. So again, we're going to use function notation, but realize f of x is equal to y. So again, this is where quadratics, all those quadratic functions we've been dealing with, this is where all quadratic functions come from, is this basic function. You can create or make all the other quadratic functions from the squaring function, the basic squaring function. So let's look at what it looks like. So this basic squaring function is a parabola. That is, the vertex is at the origin and it opens upward. And so we have these points here, so it starts at 0, 0. And when we go to -1, 1, -2 gives us 4, so these 2 points right here. And then if 1, 1, and 2, 4 over on this side. So we've got an axis of symmetries right down the middle here on the y-axis. And so it's a mirror image, so it's symmetric about the y-axis. And so this is the way the graph looks, okay? Now, again, the thing is you can take any quadratic function, right? So all quadratic functions of the form, right? F of x equal to ax squared plus bx plus c can be created from this function here, okay? So again, we're not going to get into too much of this, but we're going to, again, use transformations later on to say, hey, how can I use the parent function, the basic function of the squaring function, to graph other functions? Because if I know this, then as you're going to see, it'll be pretty easy to go from other graphs. Okay, so that's that. Okay, so now let's get to the characteristics. So here are the characteristics. Okay, so we have the domain. So the domain is going to be all real numbers. As you can see, you could put any value of x in here. There's no value of x that I cannot put in here. Okay, so then that means all x values on the real number line are in the domain. Okay, so we get all real numbers. The range, though, if you look at the y values, we don't have anything that goes below the x-axis. So the range is from 0, notice it includes 0. So 0 to positive infinity for the y's. And then decreasing. Okay, again, remember, as we walk from left to right, what is the graph doing? It's going downward. So as we go from left to right, it is decreasing from -infinity to 0. Okay, notice the parenthesis, we don't include the endpoint. And then increasing, it changes direction, now it's going up. So from left to right, starting at 0 to positive infinity, it's increasing. Okay, so that's the behavior of the graph on the entire number line. Now, continuous. Obviously, it is continuous everywhere, because you could take your pencil and trace this without ever lifting your pencil up off the paper, and so it's continuous on the entire number line. Okay, and so that is the characteristics of the squaring function. So make sure you know these, because this is going to be very important to when we start getting into transformations and translations and things. Okay? Have a great day.